Moving forward, we're excited to have Jason Lopatecki, CEO and co-founder of Arize AI, as our speaker today. Jason will delve into path to production, LLM system evaluations, and observability.
How's it going? So we're Arize, LLM and ML observability. I would say the top ML teams in the world actually use our software. So if you think Instacart, Etsy, Uber, Spotify, Discord, all have kind of centered on our software. And what it means for us is just, I see a lot of production. I see a lot of this stuff in production. I probably see more and have seen more LLMs in production than I think any other team out there. So it's a world and sea change. Last quarter to this quarter, people are getting to production, and as soon as they get to production, they kind of need an observability solution. So today I'm here to talk about observability and evaluations. So what is observability? It's not a red light or green light. It's about finding the thing that's causing that problem. And in ML, different than infrastructure, a lot of times you're using that data to build the better next model. So it's not just finding the problem, it's collecting that data and using it for fine tuning. And so let me talk a little bit about what's the journey people are taking to bring LLMs to production. How many of you have heard of the concept of the arena? Anyone? No one here. Okay. So this is like a San Francisco AI phenomenon, a term, and it means this certain region in San Francisco where all the current AI startups are. And they talk about it. Are you in the arena? Are you there? If you're not there, you need to be there. Well, my comment to all of them and all of you is that if you're not in production, if you're not delivering your product to the real world, you're not in the arena. And what does that mean? Well, you see a ton of Twitter demos. They're all over the place right now. It's really, really easy to get something to work in a simple environment. But it's very, very hard to take that simple thing and put it into the real world and make it work. And that's the challenge that's a challenge of everyone today in trying to make an LLM go from a cool little demo to make it work. And let me give you some real examples. These are real examples, which are customers we have that are live on some real use cases that are driving revenue. Common use case we're seeing is called chat to purchase. You describe what you want from a vacation perspective. The chat kind of elicits information about what you want more to help kind of build that product that you might want to purchase. And a lot goes on under the scene here. So it's not just a simple one model. There's actually a chat, which is an LLM. There's an extraction. Most people are using an LLM. There's a ranking model typically in here. And then there's a chat generation on the backside of this. So there's quite a lot that goes into this. It's not just one simple LLM. And what it means is there's a lot of places things can go wrong. There's even some spots where people are using search and retrieval, which we'll talk a little bit about today. What makes up these? Sometimes people are using chains and agents or at least chains, Llama Index, LLM Chain, as part of the chat portion of this. A lot of teams are building their own too. There's extraction, just a lot of places where things can break. And so you really need observability as you're trying to get these to production. So in the last year, as we've kind of put a lot of these and lived a lot of these in production, these are the areas that we've found you really need to think about. First off, we're going to spend a lot of time in evaluations today. Almost the whole thing's on evaluations. But there's also LLM traces and spans. It's different than traditional infrastructure traces and spans. They tend to be kicked off by LLM Chain and Llama Index, these app frameworks that generate an immense amount of distributed system calls in a small little contained couple lines of code. There's prompt engineering, and I know we're all prompt engineers, but production prompt engineering tends to be bringing data from recreating the issue in production with the data in production with your prompts so you can iterate. So it's different than maybe the playgrounds you might have with OpenAI. Search and retrieval, if you've been on a rock and you haven't heard about search and retrieval, it's everywhere. It's how you make models today, use private data, and respond relative to your data. And then fine tuning is I would say growing, I would say lots of talk of fine tuning. In terms of true production people fine tuning, it's actually much smaller than the hype out there, but expected to grow, and it's a way in which you can use data, use your own examples, use the model to respond in the way you'd like it to respond to based upon data you built and fine-tuned with. So today we're going to talk about evaluations. So evaluations. So there's evaluations is this broad term you're going to hear out there. And first off, model evaluations are different than production task LLM evaluations. And you probably, some of you probably haven't even heard of any of these, so let me talk about model evaluations first. If you've gone to Hugging Face, you'll see a leaderboard like this. So Hugging Face has a leaderboard that shows the open source models, runs these evaluations, and each one of these columns is like a GMAT, an SAT. Hello Swag is finish the sentence. And they're all these like little test suites that you test the models against. And you can rank your model and see how well it does. And the challenge is it's kind of perfectly useless for corporations. Like many of these models are trained on these data sets. They're not task specific. The prompts are all over the place. It gives you maybe a gut check. It's a nice way to feel good about the model you built is at the top of the list. What we think about and care about, and what I'll talk to you about today, we have a Phoenix library for this, but if you don't use our library, you're going to be doing this anyway, which is really task-based LLM evaluation. And so focusing on very, very specific tasks, and it's different than the model evaluation in that I'm not trying to rank my model and figure out what model to use. A lot of times as a corporation, you're already stuck with whatever, if you here, I would say you have your model you're going to use, and for example, Palm in this case. And what you're really trying to do is understand if the LLM system you built is doing what you want. And what people do with these is they use another LLM, that people call it a judge LLM or eval LLM, to evaluate the responses of your LLM system. I know it sounds crazy. We're generating with one thing and we're evaluating with another. Maybe it's the same thing, but it's not that crazy. We have humans evaluate other humans. As these tasks get more complex, this is absolutely going to be everywhere. It doesn't get around human labels. It doesn't get around all the other things you need for this. You need to just double check this. But we've done it at scale. We've seen it at scale. We've double checked with human evals on the same LLM evals, and this works. And it gives you scale. So what does this mean? Like, what it means is you have one LLM. You have a template. So you have a task template. And I'll go into a little more detail on it. And it's judging what your main LLM is doing. So these are LLM task evals. What does this look like? Well, it looks something like this. So Retrieval, I see this right now all over the place in Retrieval. If you're doing Retrieval and you're not using evals, you're never going to get it to work. If you're doing Retrieval and you're not using evals, you'll never get it to work. Now, you might get it to work for a Twitter demo, but it will not work in production. You will get questions that are different than your Twitter demo. You'll get questions that you don't have documents for in your Retrieval set. And the way in which you understand this is you run an LLM to evaluate your Retrieval. You use an LLM to evaluate your questions and answers. In this case, there's a template here that says, given this question, does this chunk that was returned from my vector store, my vector lookup, have any information that helps answer the question? LLM is rock solid at doing this. And you get an indication whether that chunk was relevant or not. It's a relevance eval. So this kind of helps you with your Retrieval, but you also do one with the question and answer too. So was the question answered correctly given these chunks? So this is an LLM evaluating an LLM. And what does it do? Well, what we also recommend is we've come to the conclusion that having a simple binary output is really nice because you can do precision recall. Those of you in kind of traditional ML realize you can find problems and holes. You can, in this case, you can look at your predicted class versus your your ground truth class. And typically what we're doing is the ground truth comes about from humans. Like normally we're testing these in the beginning relative to human evaluations. But then when you launch in production, you use it without the human. You're using this as the proxy for truth. And what does this mean? Well, it also means when new models launch, I can run it across all the tasks, across test data sets, and I can know right away, like, is this model good at this task? And the tasks we have, sometimes we have some preset tasks, but I'm seeing corporations build their own eval tasks they care about. Like I've seen people do this very, very specific internal code generation for this internal code tool they have, their own data sets. But you build your data sets, your task, your eval, and then when these new models come out, you can see if they work well. Well, in this case, Palm works great for the Q&A eval, but the GPT 3.5 Instruct, which was launched a couple months ago, is not good for it. So you know right away whether you can use this for the task at hand. And what the fundamental thing that we have Phoenix in this little library. It's open source. You can download it. The core principles that we have is, one, you should definitely have a data set, a golden data set around whatever task you've come up with. You need a template, which drives it. You need the model that you're testing against. And then the harness we have is just designed to run across all environments. So if you're using LangChain, that eval should run in LangChain. If you're running a pipeline, it should run in a pipeline. And for us, like, there's a lot of things we ran into from the harness perspective. How does it run fast? Do you have to, how do you fork a bunch of calls? What happens if you want a checkpoint? It falls short. You're running a bunch of evals on a 100,000 line, 100,000 samples, which could be expensive. What happens if it fails halfway through? So all these things around that come about of trying to run this at scale, run this continuously is problematic. And check out Phoenix. It kind of handles some of these things. So some of this is like the different places I might need to run evals. In a notebook, in a collab, when you're kind of building, I might need to run it in like the pipeline pre-production for just experiments. I want to do a bunch of experiments, and then I might want to do production with either pipelines or Llama Index or LangChain. So your evals need to run everywhere. And so I'll spend a little time talking about one in more detail. I kind of did search and retrieval. I did search and retrieval a little bit back there. And from a search and retrieval perspective, you typically have a query, which comes in as a question. There's typically an embedding of that query into an embedding a vector. There's a vector lookup, which is why all the vector databases have started to grow in popularity. And then you have these chunks returned. The chunks represent the information relative to the question. That's put in a context window for the generation. So this is kind of search and retrieval. You're hearing about it. You should be hearing about it everywhere. It's really how, again, private data is connected to LLMs, and so this kind of magical way of connecting private data to your LLMs. But the question is, like, how do you make this work, and how do you troubleshoot it? So when for search and retrieval, what you might look like, it might look like something like this. So just going into the real details. You might have your query. You might have chunks from your docs. This is a query on like our docs, a chunk set of docs returned. Do you need a prediction ID in the training set? How do you configure GPQ? And some of those contexts are relevant to the question. I might get irrelevant content and then a poor answer at the end. And the evals can actually help you with the full suite. So we talked a little bit about the relevance one earlier, which is checking whether the first context is actually relevant to the question. There's another eval that's typically done. That's the Q&A eval. So it takes the two chunks of data, it takes the query, and it takes the response. And it just says, is the response correct based upon the chunks of data? Does this answer look right? And what we've, there's this subtle thing we found, which is that I honestly think LLMs are better at seeing if they're right, given all the data, than maybe they are at generating that first answer. So you can even use the same LLM if you're using Palm, for example. You can use that same LLM to judge yourself, and don't feel weird about it. I know I did in the beginning, but I got over it. Just test enough to make yourself feel that you're comfortable with what you're doing, and then have some data, have some golden data sets to test against. So for retrieval, we recommend a relevance eval, are the chunks correct, and a Q&A eval to make sure the answer and question are correct. Those are the core two. If you're doing RAG, have these evals in place. So what does this mean? Well, if you're using LangChain or Llama Index, what typically this stuff looks like is they're actually in these LLM traces and spans and in a chain. The top of the chain might be your Q&A eval. The other portions of the chain will be doing other things like your retrieval. So what it means for the more complicated environments is that evals need to run on spans. So there's a span that's a retrieval span. There's a span that's a Q&A span. And your evals are actually running on different spans here. So it gives you an idea of the complexity as you start to use these frameworks. The eval that you've built in your collab environment now has to be run in the callback system of the frameworks. So there's a lot that starts to get unpacked as you dive into this, not necessarily so simple. So I do want to give a plug for Phoenix. It's open source. Been working on it a lot. A couple months ago, we put it out there already. I think we're pushing close to 2,000 stars. And it's got, for us, it's really, we're passionate about making models work, evaluating models, understanding them. And I would say that the strengths and the things you run into and the things you're going to need are, one, it's designed to be really fast. There's other libraries out there, but when you're doing these batches of data, you want to fork and make sure you're filling every possible call. We're also adding the ability to span across data centers if you want to use multiple limits at once. I think it's 10 to 100 times faster than some of the others. There's things about failed runs of batches where you want to checkpoint it and keep running. There's explanations now. Explanations are awesome. One flag, you get an explanation for your eval. Very, very powerful in debugging to be able to understand, okay, it says it's not relevant, but why? What was it missing? And then all of it's editable. If you want to edit your template or create new templates or whatever, we support obviously Palm, Palm heavily, Vertex AI, all the stuff's kind of out of the box. Really great library. And then you can see there's also a separate piece for visualization on top. So there's a visualization layer that you can visualize your calls in your system. You can visualize these. It can capture the LangChain and Llama Index traces, and you can run your evals from these traces. So this is Phoenix. Please check it out. Give it a star if you use it and like it. What I wanted to do is give a bit of a, let's see if this works. Bit of a demo. Okay, roll video one. So what I have here is an example of just Phoenix. You're in a notebook, it runs on Colab, so it runs on your Colab server locally. You can click a link, you can end up in Phoenix from your notebook, from your Phoenix server. And if you're running LangChain or Llama Index or even the APIs directly, it collects all the traces. So all these spans and traces get collected as these calls occur. So in this case, I have a retriever. I have some retrieved docs chunks here. I have some information on timing. Just a great way of seeing everything that's going on. Again, it's local. This is not SaaS. It's runs local on your data. You can see what templates were used, what templates were used by, if you're using, again, these frameworks templates are sometimes just deep in there. You can see what was called on those. Really awesome debugging solution. Just collect all the information you need in the first place to run an eval. So this gets collected, you can troubleshoot, you can see your spans, but then you can be back in your notebook and you can make calls where you pull it back to the data frame, these data frames of whatever spans you want. I want the retriever spans. And then there's a whole library to run the evals back in the notebook. So Phoenix is this, there's a pretty powerful set of evals that you can then run back in your notebook and visualize performance for anything. So it's a, visualize, collect spans, come back to your notebook and run evals. Really awesome solution for that. And so this example here is running like a relevance eval that we were kind of showing you back there. A lot goes under the hood of the stuff, but very usable to collect data, run evals back in the notebook. So this is now production. So that eval, this is the cloud platform. That eval is over time, which is what you want in production. I want to be tracking this eval over time. I've got a drop in my eval there for relevance. And so I want to kind of zoom into that period. I want to kind of think about the points. I want to look at the context for this specific point that were inserted and problematic in that period. And it's a question around our docs here. And then I might want to come in, and this is my comment on the playground, where the playground might be very different. I want the data integrated at this point I'm looking at. I want the context returned and the prompt template working together, and then I can edit it. In this case, the prompt template didn't say, if you don't get the answer in the chunk, don't respond, I don't know. You can add it in, you can see that response. I might want to compare two periods of time. So my evals look different over 2 periods of time, and maybe it's because I launched a new prompt template. So maybe I want to drop a filter for the prompt template that I just added today. I want to compare the evals between those 2 new templates I launched. So I can pick 2 different periods. I can look at the evals. And again, it's about once you generate these evals and you trust them, you can use them to debug things. You can use them to track down things. I can drop in these evals on the right here of was it relevant or not? And then in this case, if I'm trying to debug embeddings and embedding search and retrieval, there's embedding views to search for periods of time where my relevance has dropped. And I just want to look at what's going on. Why am I, what's broken in this period? So these are embeddings. Greens are queries. Purples are chunks for my vector database. I'm sorted by the clusters where the worst at the top is the one where everything's irrelevant. Everything in this group is just returning nothing. And when I click on this, I might look at this and say, well, what's going on? I can click on them. And to be honest, this is pricing information. We don't have pricing information in our docs. Go figure. So everything's irrelevant. But maybe I don't want to sort through them. I want to hit a cluster and just summarize. So you can summarize the cluster. We support PALM, so you can just connect to PALM, and PALM summarizes this cluster. So how do these evals help you troubleshoot? How do LLMs help you understand the group of data you're looking at? This is kind of what it looks like. So just wanted to kind of run through what production troubleshooting looks like. Definitely check out Phoenix, Arize. A couple minutes, are questions okay or no questions? Are questions okay? Okay. No questions. Okay. Well, thank you, everyone. You know what? We do have our team over there at a booth if you want to ask questions in more detail of the group out there. Super appreciate the time. Thank you.